Okay. Actually, let me, sorry. Okay, there we go. Okay, so this is the review for exam number 2 for Math 1350. If you have questions, for those of you online that are watching this like currently, you can send me a message through the chat, or I have volume in this room, so you feel free to just ask out loud whatever your questions are. Okay, so what do y'all want to go over? Number 7. Okay, so look at number 7. Number 7 on the review wants you to draw 1 and 2/3, and it wants you to use the set model, the area model, and the number line model or the length model. So if I wanted to do, let's do the area and the number line model first, because I feel like the discrete one's the hardest part. So area model, if you wanted to use pattern blocks for this, you can use pattern blocks for it, or you could do it with the rectangles like this part. I'll show you both. Okay, so with the area model, if you want to use pattern blocks, feel free to use pattern blocks. You just have to make sure with all of these to tell what your whole is. So if you wanted to say that the yellow hexagon equals the whole, then 1 and 2/3 would be 1 whole, and 2/3 of that whole. So we need to figure out what splits that whole into 3 parts. To split it into 3 parts, that would be the blue ones. Okay, and I want to use 2 of those parts. So this would be my whole right here. This would be 1/3, 1/3, and 1/3. So I want to shade in 2 of those. Okay, so that's how you can show the area model with pattern blocks with 1 and 2/3. You could also use the rectangles to do area model. Okay, so if you were going to use the rectangles, this is one sufficient way to do it. The other way is, let's say, so we're going to let that rectangle equal 1. So 1 and 2/3 would be 1 whole of those plus another split into 3 parts. This is 1/3, this is 1/3, this is 1/3. So this would be the 1 and 2 of those, 1 and 2/3. Technically, you're supposed to show the whole part. So either one of those would be sufficient answers. So that's for area model. For the length model, or the number line model, you could use Cuisenaire rods. It might be a little bit of work to figure out. So let's see. I'm going to guess that I can split that one into 3 parts. Let's see if I can. The dark green. You can. So you could say, if you wanted to use the Cuisenaire rods, feel free to use them. You would say, let the dark green equal the whole. So then 1 and 2/3 would be 1 dark green. You could shade this in green, and then 2 more reds. This is red and red because that's 1/3 and 1/3. So that's one way you could do it. I think the easier way to do it, not using the Cuisenaire rods, would just be to use a number line. So if you used a number line, that would be, so we're going to say this is 1 whole right here, and this would be 2 holes. I mean, you could go up to however much you wanted to. But to show 1 and 2/3, we need to split each whole into 3 pieces. So this would be 1/3, this would be 2/3, that would be 1 whole. This would be 1 and 1/3, 1 and 2/3, 2 holes, 2 and 1/3, 2 and 2/3, 3 holes. Okay, so 1 and 2/3 would be the length of 1 plus 2/3 more. Okay, so that's how to show the area model and the line model. The set model is the one that's a little bit, I think, trickier just because of the instructions. It says with set size greater than 2, each circle needs, and that basically just says each circle needs to have more than 2 dots in it. So what that means is our whole needs to be some set that when I divide it into the 3 parts, each of the 3 groups has more than 1 dot in each group. So basically you can't start off with 3 dots as your whole. So let's start off with 6 dots as our whole, or 9 dots, like something that's divisible by 3, because I need to split it up into thirds. So I'm gonna do 6 dots. So let this be your whole. So to show 1 2/3 would be 1 whole. Okay, so 1, 2, 3, 4, 5, 6 dots in it. And then I need to show 2/3. So I need to split this into 3 pieces. So that's 1 piece, that's 2 pieces, that's 3 pieces. So this is 1/3, this is 1/3, this is 1/3. I'm sorry, so this is 1 whole. The 2/3 would be the 2 more pieces, 1, 2. You could, if you wanted to, you could draw the whole thing, and then like just shade in the dots, or you could just draw the dots. Either way is fine. But if I shaded in the dots, this would be, I'm shading in all of these, and I'm only doing 2/3 here. So that would be 1 2/3. Okay, so that all those instructions just mean pick a set that has more dots in it than, like if you just did 3 for your original set, then you would have 1 dot in each, and it gets a little bit confusing. I was trying to help you out by saying pick something bigger than 2 there.
I do have a question with that.
Yep.
So whenever we do a problem like that, do we have to specifically say the total number of dots, or it's okay just to draw it out?
You have to tell what your whole is, because like this is a good example. And I could do this exact same problem, but I could have used the red trapezoid as my whole, and your answer would look different that way. It would be 1 red trapezoid and 2 green triangles, and that's also a correct answer. So either one's fine. You just have to tell what your whole is. Same thing here. This rectangle could have been this long, and if your rectangle is that long, then your answer would look different, because it would be this long and then 2/3 of that. Does that make sense?
Yes.
So it doesn't matter how you do it. You just have to make sure you tell the original, the whole, so that I can check and make sure that your answer is correct based on your whole.
Okay, thank you.
And kind of same thing with this Cuisinart rod. I just picked dark green. You could pick something else also. That was the first one that I picked that worked.
Okay.
Does that help with the set model though? Was that your question, specifically the set model?
Yes.
Okay, does that help?
Yes, ma'am.
Okay. What else?
I needed help with number 11 as well.
Number 11, okay. So for number 11, that is 24 divided by 4. And we want to use repeated subtraction and partitioning. Okay, so starting with repeated subtraction. The thought process there is start with 24, and then we want to subtract 4 until we get to 0. So you could use like a set model for that or whatever, or you could just literally just subtract off 4. So 24 minus 4 would give me 20. 20 minus 4 gives me 16. 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4, and then 4 minus 4 is 0. So we subtracted 4 until we got to 0. Our answer is how many times you subtract. Okay, so I subtracted 1, 2, 3, 4, 5, 6 times. So my answer is 6. So 24 divided by 4 equals 6. I use a number line to show repeated subtraction. Yes, that's fine to use a number line to show repeated subtraction. Yeah, you could do the same thing like on a number line, go to 24 and then subtract off 4, and your answer would be how many times it took. That's not a good picture, because that's more than what it's supposed to be, but you get the idea. Okay, so that's for repeated subtraction. For partitioning, the idea of partitioning is, I write it down first, partitioning. The idea is start with 24 things and put into 4 groups. Your answer is how many in each group. Okay, so if I start off with, let's see, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, start off with 24 things and I'm putting them into 4 different groups. 2, 3, 4. So I'm putting them one at a time in each group. You can sit here and do all of them one at a time. I'm going to save a bit of time, and we know that we're going to end up with 6 in each group. When you mark them all off. And so my answer is how many are in each group? So 24 divided by 4 equals 6. Okay, so that is number 11. We're going to move on to 15. Number 15 is greatest common factor by listing all factors and using the prime factorization. So for number 15, the GCF of 32 and 24. So the first way we're going to do it is by listing all the factors. Factors of 24. These are things that multiply to give us 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. The factors of 32 are 1 and 32, 2 and 16. 3 doesn't go into 32, 4 does, 4 times 8. And 5 doesn't, 6 doesn't. So those are your factors of 32. So the greatest common factor is the biggest number they both have in common, which looks like it is 8. So the greatest common factor of 32 and 24 is 8. So that's one way to show the greatest common factor. That's actually kind of the longer way, depending on how many factors you have. The shorter way is to use prime factorization. So we break down our 2 numbers into the factor tree, the prime factors. 32 is 8 times 4. 8 is 4 times 2. 2 is a prime factor, but 4 is not. So I can keep on going. 4 is 2 times 2. I can do the same thing with this 4, 2 times 2.
I have a question.
Yep.
With the 32, how do you know what numbers you start with? Like I had wrote down 2 and 16.
We should get the same exact answer, and that's called actually the fundamental theorem of arithmetic that says that every number breaks down into a unique set of prime factors no matter how you start. So like if you notice, if you did 2 and 16, 2 is done, but 16 breaks down into 4 and 4, which is 2 and 2, and 2 and 2. And so you get 5 2s no matter how you do it.
Okay, got it.
Okay, so 32 would be 2 times 2, 5 2s. 24, you could start with 6 and 4, you can start with 8 and 3, you can start however you want to, but you should, no matter where you start, end up with 3 2s and a 3. So 24 is 3 2s, 1, 2, 3, and the number 3. And your greatest common factor is all the factors they have in common multiplied together, all the prime factors. So they both have a 2, they both have a 2, they both have a 2, and that's all they have in common. So your greatest common factor of 32 and 24 is 2 times 2 times 2, which is 8. You pick one from each group right at one time and multiply them together to get 8. So same answer both ways, just 2 different ways to do it. Questions about that? Okay, we're gonna move on to number 16. 16 is least common multiple. And we're gonna use all three ways to do this one. So least common multiple of 8 and 18. The first way we're gonna do it is by listing all the multiples. So multiples are 8 times 1, 8 times 2, 8 times 3, 18 times 1, 18 times 2, 18 times 3, so on and so forth. So multiples of 8 are 8, 16, 24, 32, 40, 48, 56. Keep on going. We might need to keep on going. Let me do the multiples of 18 and see if we need to keep on going. 18 is, let's see, 18 is 36 is the next one. Let me give a calculator. 18 times 3. Hi, come on in. 54. The next one is 72, which I need to keep on going. Let's see. That's 8 times 7. 8 times 8 is 64. 8 times 9 is 72. So this is the smallest one they have to find. Ready, Stephanie?
Yes.
Okay, so your least common multiple of 8 and 18 is 72. And you kind of don't ever know how long this list is going to be. Like it could be like super duper long, or we could have found it like super quick. So that's kind of the annoying part about listing it out that way. So the faster way to do it is with the prime factorization, where we break down the numbers. 8 is 4 times 2, and 4 can break down into 2 times 2. So 8 is 2 times 2 times 2. Number 18 is 9 times 2, and 9 is 3 times 3. So 18 is 2 times 3 times 3. And the prime factorization, the least common multiple of 8 and 18 is you find the greatest common factor first, which in this case is just 2. So you write that number down one time, the greatest common factor, times everything that's left over, and you write all of the numbers that are left over. So 2 times 2 and 3 times 3. So this 2 came from that pair right there, and then these came from those 2 right there. And so your answer is multiply all that together. 2 times 2 times 2 is 8, 3 times 3 is 9, and 8 times 9 is 72. Okay, for part C, C is very similar to A because you're just basically putting these numbers on a number line and seeing where they match up essentially. Okay, so on a number line, we're going to do the multiples of 8 first. So we're going to say that's 0. The first one is 8, and then 16, and then 24, 32, 40. You could also, I'm putting like the multiples of 8 on my number line. Technically, you can make your number line go by 5s, like 5, 10, 15, 20, go by 10s. It doesn't really matter how you do it. Just put some numbers on your number line. So let's see, 48, 56, 64, 72. That's where they're going to be. I'm going to do one more, 80. So on my number line, this is the multiples of 8 are all those different ones. And the way we get to each one is by adding 8 each time. So this is like plus 8, so on and so forth. I'm going to do the same thing underneath, but I'm going to do multiples of 18. So the first multiple of 18 is 18, which is like right there. So it's going to bounce to 18 first. The next multiple of 18, come on in, is 36. 36 is going to be about right there. So it's going to bounce to 36. The next multiple of 18 is 54, which is right here. So that's the next one. And then the one after that is 72, which I already have, which is right here. So they meet at 72 is where they both hit the same number. So the least common multiple is 72. Okay, so that was 16. So number 17 now. Okay, so look at number 17. It says Venn diagram. Oh, okay, to do these. So the Venn diagram for the greatest common factor and least common multiple of 20 and 36. Okay, so to do both of these is we need to find the prime factorization for your Venn diagram. So 20, I'm going to break down into my prime factors, is 2 times 10, and 10 is 2 times 5. And for the number 36, the prime factors of 36, let's see, if I start off with 6 times 6, I get 2 times 3 and another 2 times 3. So the Venn diagram, I'm going to have a circle here. This is prime factors of 20, and this one is prime factors of 36. Okay, so in the circle of 20, in this circle right here, I need 2, 2, and 5, somewhere in that circle. In this circle over here, I need 2, 3, 2, 3. Oh, sorry, not that. 2 and 3, 2 and 3, somewhere over here. So what do they have in common? Well, they both have 2 2s. So let me put those in the middle where they're going to overlap right there, because they both have the 2 2s in common. What's left over here on 20 is just a 5. Left over here on 36 are the 2 3s. And you can check this. If you cover up the circle of the 36 and only show the circle of 20, do these factors multiply to be 20? 5 times 2 times 2. 5 times 4 is 20, so that works. If I cover up my circle of 20 and only see the circle of 36, 2 times 2 times 3 times 3 is 4 times 9, 36. Yes. So that's the Venn diagram. Okay, so the question is, where is the greatest common factor at? Well, the greatest common factor is the factors they have in common, which would be the center right here. This is the greatest common factor, is 2 times 2, which is 4. And if you wanted to work these out, like the factors of 20 are 2 times 2 times 5. 36 is 2 times 2 times 3 times 3. You could double check. Your greatest common factor is what they have in common, which is 4. The least common multiple, remember, we use the greatest common factor, but then we also use all the other stuff. So there's the greatest common factor. Here's the other stuff on the outside of the circles. So the least common multiples is just everything in the circles, which is the union. Okay, so the least common multiple would be 2 times 2 times 3 times 3 times 5, which is, let's see, 20 times 9 is 180. Did I do that right? 4 times 5 is 20. 20 times 9 is 180. Yeah. Okay, so it's kind of similar to the problems you've done already. We're just putting them in a Venn diagram to see where those things are located at. For number 18, this is the day that we did the all the different types of numbers. Okay, so they're listed in order here of, didn't we do like the Venn diagram in the video of this? I think it was the Venn diagram, where like complex is the biggest number. So like, paper. So like all numbers are considered complex. Every number you could ever think of until they come up with a whole new set of numbers. But as of now, everything's complex. And then from there, we have real numbers or imaginary numbers. Okay, imaginary stops, like it's just imaginary. There's no other options after that. From real, we have the option of irrational numbers and rational. And then rational numbers, we have integers, isn't that the next one? Yes, integers. And then within integers, we have whole numbers. And then within whole numbers, we have natural numbers. So that's one way to look at it is like that, or another way to look at it is like if you did a Venn diagram or like it wasn't really a Venn diagram. So like we're gonna say this whole thing, let's do it like that. We're gonna say this whole thing is complex. So then within complex, I have some that are imaginary over here, and then everything else is real. Technically, I wouldn't have anything outside of this box at that point. But then within real, I have some things that are also just integers. And then I have things that are also just whole numbers. And then things that are also just natural numbers. So that's kind of two different ways to think about it. Okay, so if you have something that is an irrational number, it is also real, it is also complex. If you have something that is an imaginary number, it is also a complex number. Like it's every name above it. If you have something that is rational, it's also real, it's also complex. If you have an integer, it's also rational, real, and complex. If you have a whole number, it's also integer, rational, real, complex. So it's like you follow up the list for all of them. So natural numbers are numbers that are counting numbers, not including zero. So 1, 2, 3, 4, 5, 6, so on and so forth. Okay, so a natural number is also a whole number, also integer, also rational, also real, also complex. A whole number is the same as natural numbers, except we also add the number 0 to it. Okay, so 0, 1, 2, 3, so on and so forth. An integer is a positive or negative whole number. So it's all of these numbers from before, 0, 1, 2, 3, so on and so forth, but then I also go the other way. -1, -2, -3, so on and so forth. Rational numbers is all of these integers plus all the fractions and decimals in between them. They can be written as fractions, technically. Okay, so I can't really list that out like that. So this is just everything that can be written as a fraction. So like 1/2, 1/3, 1/4, 1/5, 1/6, 1/7. Like I could be here all day because then I could say 2 7s, 3 7s, 4 7s, 5 7s, right? That's why I can't really list them out. So anything that can be written as a fraction. Irrational is the weird numbers that can't be written as a fraction. We talked about this at the beginning of class. Oh, no, sorry. That's in my other class. In 1351, you'll learn more about irrational numbers. But weird numbers like pi, in college algebra, you talked about the number e. Also square roots, square root of 2, square root of 3, not square root of 4, square root of 4 is 2, and that's just a rational number. Square root of 5, so on and so forth. And then imaginary numbers are numbers that have an I in them, like 3i or 7 plus 5i or something like that. So for these problems, you have to pick the number and tell what category it falls in. So 0. So for part A, 0 falls in. It's not a natural number because 0 is not in that category. It's a whole number. So 0 is a whole number, an integer, a rational, a real, and a complex number because it's everything on the list above it. Square root of 3 is an irrational number. So it's irrational, real, and complex. Pi, irrational, real, complex. The number 2 is natural, whole, integer, rational, real, complex. Okay. 2/3 is just a fraction. It's not an integer or anything below it, so it's just rational, real, complex. And then -4 is integer, rational, real, complex. Okay, what else? Jasmine? Jasmine, I think we covered all the questions that you sent in so far. Let me know if you have other questions.
No, I'm good. That's all the questions I had. Thank you.
You're welcome. Anybody else have other questions?
This is 1350, right?
Mhm.
Okay.
Yeah, I got confused for a second. We went over this stuff more in the other class.
Oh, actually, yes. Like what we covered on the last 2 homework assignments, like with the manipulatives and stuff like that. That's what I came here for.
Okay, so like number 2 on the review. If the dark green Cuisinart rod is 3/5 of the unit, what is 1/2 of the unit? Okay, so for number 2, dark green equals 3/5. So that tells us that the dark green represents 3 parts. And it also tells me that 5 parts make a whole. I don't have the whole here. I don't actually have the 5 parts, but once I can figure out what the part is, then I can use that to make the whole. So I need to take this dark green Cuisinart rod and I need to split it into 3 pieces. Because then I can figure out what the part is here. I don't know what color the part here is. So you could sit and guess, like if I did this, that is not the right answer because there's only 2 pieces there, right? If you did red, there are 3 reds that fit in there. So that tells me that, let me draw this on here. They can't see the board if I were it on the board. That tells me that this is the dark green one, right? And this is how you would write it on your test for your answer. There's my reds. So this is my whole right here, right? That's no. Dark green is 3/5. That's 3/5. I don't know the whole here. So these 3 pieces, they each represent 1/5, 1/5, 1/5. Because if I add them up, 1/5 plus 1/5 plus 1/5 equals 3/5. These are equal lengths.
So you add 2 more reds.
So we need to get to the whole so that we can find a half. So what I need to do is to find the whole, let me find 5 reds. 1, 2, 3, that's not a very good picture, but you get the idea, right? So 5 reds is what's gonna make my whole. So 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, that equals 1 whole. So let me actually do that with my picture here. So 5 reds make a whole. And I need to figure out, and from there you could just use that as your whole, or if it actually asks what is the whole, you would need to figure out what rod that is, which is actually the orange rod. So if the question asks what's the whole, the answer would be 1 orange rod is the whole. Okay, the question asks what's 1/2. So now I can find 1/2 from here because I know the whole. To find half, figure out what 2 pieces fit in the whole, which the yellow, I don't know, I'm guessing. Oh, look, there you go. It's yellow. So from there, 1/2 would be what 2 pieces fit in there, which is yellow. I don't have a yellow color here. So that's 1/2, that's 1/2. So my answer here, 1/2 is yellow.
But then they used to confuse me about that one because you know how it says 3 is the parts that you have?
Mhm.
So I would think like I need 3
greens. No,
But you
yeah,
have to split it up.
yeah.
Okay.
I was just confused about it in general. I got the phone manipulative. By chance, do you have spare
Are you taking the testing center or a virtual?
virtual?
You gotta use your phone ones. But if you're taking the testing center, they have these that you can use.
Because it's like those are more accurate than these. That's why I was like,
But let's talk after I'm videoing this. Let's talk after that. Real fast, let me go ahead and make a comment about this. For your exam, I sent out an email. You have to sign up through the Google Doc and you're supposed to submit to me the quiz. The reason why there's two things there, signing up through the Google Doc signs you up with a proctor, and I don't have access to proctors. I can't touch any of that. So you have to fill out that Google Doc if you want to do it virtually, because that's what gets you the Zoom link and signed on to the Zoom meeting. The filling out the quiz for me is to tell me what time you signed up for your exam so I can put it on D2L and make it available on Wednesday at 2 o'clock or on Thursday at 10 a.m. So that's why there's two things there, because there's two parts to the test, like two ways the test is happening. There's the proctoring side of it, but then also the test on the D2L side. So that's why I need everybody to send me both things or do both things, unless you're doing the testing center and it doesn't matter what time you take it. I just send it over there. Okay, so if you did not fill out the quiz, it was due last night at midnight. If you did not do that, I need you to send me an email telling me what time you're taking your test. And I need you to do that ASAP, because I need to get all those tests posted like tonight. That's what I'm doing tonight, is getting them all posted. Okay. Also, when you take your test, you need to bring your manipulatives. Like if you're taking it at home, you need to have your manipulatives out with you. And I'm telling the testing proctor that you're allowed to have those. If you're taking in the testing center, they have a set there. So make sure you have all that. You can also use matte pencils or crayons or markers or whatever you want for colors as well. Okay, so she also wants to go over 6 and 13. So let's look at 6 and 13. Number 6 is, it says, if this group of dots below is 4/3 of the unit, then what is 5/9 of the unit? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 23, 24. So there are 24 dots here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 3, 4. So it tells us this is 4/3 of the unit. So that tells us that this right here is 4 parts. And it also tells us stuff that we need to know in the future, that 3 parts make a whole. So I need to split these dots into 4 parts. There are 24 dots, so that tells me that 6 dots is in each part. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What is the name of each of these parts? 1 out of the denominator's 3 all the way through. 1/3, 1/3, 1/3.
This is gonna be improper.
1/3, yep. And when you add it together, 1 + 1 + 1 + 1 is 4. Keep your denominator of thirds. Okay, so it's asking, I want to know a fractional part of this. To get a fractional part, I have to find the unit or the whole first. What is the whole here? 3 parts make a whole. 3 of these groups make a whole. This is the whole right there. So I'm just going to go ahead and redraw them. So 3 groups make a whole. 1, 2, 3. It's 18 dots. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. This is my whole, because 1/3 + 1/3 + 1/3 equals 1 whole. From there, it's asking for 5/9. To find 5/9, I need to split it into 9 parts first and then use 5 of those parts. So let me split into 9 parts. There's 18 dots. Each group is going to have 2 in it. 8, 9, right? And we can name these 1/9, 1/9, 1/9, all the way down. And if you add all of those up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 9ths. Doesn't that equal 1 whole? Yeah, and my answer is, it asks for 5/9. So 1, 2, 3, 4, 5.
So just that part is your answer.
So that part is your answer. So you could leave that right there, or how many dots is that? 2, 4, 6, 8, 10 dots. You could also just write 10 dots, as long as you show all that work as your answer. Okay, number 13, divisibility rules. I am not gonna sit and write out all the divisibility rules here for number 13 because you have those in your notes. But the type of problem you'll have, I'll give you a problem. Let's say the problem 1, 2, 3, 4, 5. 12,345. And the question is, what is this divisible by? Okay, so we're not using our calculator for this. You're explaining with your divisibility rules. Is it divisible by 2? No. How do you know? It's an odd number. Okay, is it divisible by 3? The way you decide is you add your digits together. 1 plus 2 plus 3 plus 4 plus 5. That is 15. Is 15 divisible by 3? Yes. So yes, it is divisible by 3. Is it divisible by 4? No, because it's not even. It's not divisible by 2. Is it divisible by 5? Yes. How do you know? It ends in 5 or 0. That's the rule for 5. Is it divisible by 6? No, because it's not divisible by 2. Like, to be 6, it has to be 2 and 3. Did we go over that? Yeah, 2 and 3. We didn't have one for 7. We had a rule for 8. It has to be divisible by 4 and no. Your last 3 digits have to be divisible by 8. It's not an even number, so it's not divisible by 8. The divisibility rule for 9. Is it divisible by 9? You add up your digits and then, so 1 plus 2 plus 3 plus 4 plus 5, and then divide it by 9. Does 15 divide by 9? No, so it's not divisible by 9. And then the only other one we had was 12, and that's the divisibility rule for 4 and 3, which it's not divisible by 4. So this is just divisible by 3 and 5. So that's the kind of problem to expect on number 13. Okay. Anything else? Do you want to go over number 3, the pattern blocks?
Yeah, can you actually do that? Did you
Yep.
do number 7 already? Because I could go back and watch it if you did.
Yes, that was the first problem we did was number 7.
Posting this on YouTube?
Yeah, I'll post the link on D2L this afternoon after it loads. Okay, so for number 3, pattern blocks, you're told that the yellow hexagon represents a value of 1. So this equals 1. We want to find 7/3. To find 7/3, 7/3 tells us a few things. It tells us we need 7 pieces in our answer, or 7 parts. I think that's what I've been saying. 7 parts and 3 parts make a whole. I have a whole here. I need to split this into 3 parts to figure out what my part is in this situation. Okay, so you use your pattern block and you see that 3 blues make a whole, right? So each blue is 1/3, right? 1/3 plus 1/3 plus 1/3 equals 1 whole. So if I want to show 7/3, I need to show 7 blues. So there's one set of blues right there, which is 1, 2, 3 blues. Here's 4, 5, 6 blues, and here's your 7th blue. So you draw that on your paper. You could literally say 7 blue of the parallelograms. You could also say 2 yellow hexagons and 1 blue rhombus. That's an acceptable answer also. Like, I would just draw this. I would draw 3 of the, if I was going to draw my answer, I would draw it like this. Ooh, that's a bad one. And I would show them broken up into the 3 parts. And I would draw 1 more of them, and I'd shade them all blue. And you could label them if you wanted to. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, and 1/3. If you add all those up, you get 7/3. Any other questions? No, we can do number one. For number one, it says the yellow blue rod is your hole for Cuisinart rods. So this is my hole. And we want to find a half, a third, a fourth, a seventh. So 1/2 would be what 2 rods fit in there, the same length, not that one. Let's see. Is it black? Let's try black. There you go, 2 blacks fit in there.
So that's 1/2.
So black is 1/2.
And then the third would be 3 pieces.
3 pieces fit in? So see if you can find 3 pieces that fit. It is not dark green. Try yellow maybe? Not yellow. What's one smaller than yellow? Purple? Purple one's smaller? Yeah, purple's the one that's smaller than yellow. If I try purple, will it fit? No. So there is nothing, like yellow's too big and purple's too small. So there's nothing that makes 1/3. If I did 1/4, can I fit 4 of anything? Purple's too big for 4 to fit in, so let's try the one below that, which is green, I believe, light green. The one below. Yeah, that's one below. I'm gonna take the purple and the yellows off because I'm done with that problem. Will 4 of these fit? No. 4 is too small, but the purple is too big. So there's nothing for 1/4 either. For 1/7, you do the red. 1, 2, 3, 4, 5, 6, 7. I believe 7 reds fit in there. Yeah. So red is 1/7.
So you only have to show your work for the 3 ones that actually have. rods.
Yeah, you would just draw this picture right here. Okay, so I posted the solutions for this. We've actually worked out almost all of these problems. I posted the solutions for this on D2L last week, but I can post it this week also if you need me to. It's on week 8 under documents, so you can go check your work with all that. Make sure you go back and look at your homework and see what you did wrong on your homework. Today I'll post all the solutions from the homework as well, so you can go check your work with all that. And just make sure that you are showing up for your exam whenever you signed up to go to it. So let me know if you have any questions and I will respond to those via email.